This is the homework for Wednesday, SBAC Review, EMC number 3. For number 1, we need to determine whether each relationship is a function. And the easiest way to determine that is if the x values repeat, it is not a function. And you see here, in these two ordered pairs, the x values repeat. Now, an easy way to visualize that is, let's say x represents the number of hours, and y represents the number of miles walked. So if in 4 hours I walked 4 miles, at the same time, is it possible for me to, in 4 hours, have also walked 0 miles? No, that's not true. You can't be at 2 different places at the same time. 4 represents hours, and so 4 and 4, the x's, and the y, 4 miles total distance walked, and 0 miles total distance walked. That doesn't make sense. It's not possible. So again, the x values cannot repeat. Otherwise, it's not a function. So here's an example of this, these ordered pairs on a graph. Here, distance, number of hours, 4 hours, and I traveled 0 miles and 4 miles. That does not work. And this is an example of the vertical line test. It does not pass the vertical line test. So anytime in a graph you see 2 points that line up vertically, they have the same x value, it's not a function. So it's the easiest way to determine that it's not a function by seeing it on a graph, because you can use the vertical line test. You can see here, 4 and 4, not a function. For number 2, this is a function. None of the x values are repeating. For number 3, we have a mapping diagram. And the easiest way that I have found to identify whether it's a function or not is to write these as ordered pairs. So each arrow represents, this is the x value, the y value, and I write them as ordered pairs. 8 and 1, 6 and 9, 7 and 9, 11 and 3. And the reason why is because when I first started learning this, I always got confused. Oh, that's not a function. They both go to 9. Well, they're sharing the same y value. That is okay. They cannot share the same x value. So if the x values repeat, it's not a function. Well, you can clearly see there's no repeating x values. Sharing the same y values, the y is repeating, that is okay. So this is a function. In problem 4, the table and graph shows how many words Morgan and Brian typed correctly on a typing test. So here's Morgan's data, here's Brian's data. For both students, the relationship between words typed correctly and time is linear. So that means it has a constant rate of change. We can see a constant rate of change here because it's linear. We see a constant rate of change here because for every 30 words, she types 30 words for every 2 minutes. So remember, the rate of change or slope is the difference of the y's over the difference of the x's, or rise over run. How much is it rising? Well, it's 30 words for every 2 minutes. Well, and I got that from 60 minus 30 is 30. 4 minus 2 is 2. And you can see 30 words for every 2 minutes. And remember, the y values are going to go on top in the numerator, x values in the denominator. So 30 divided by 2 equals 15 words per minute. So that is Morgan's rate. Now we have to compare that with Brian's rate. And you can see here is 60 words. And so I had to figure out, well, what is this going by? Each interval is 20, 40, 60, 80, 100, 120. So it's going by 20s. And I see that for every 20 words, it takes Brian 1 minute. So Brian rates 20 words per minute. So you can clearly see Brian has a faster rate than Morgan. So Brian types 5 more words per minute than Morgan. For number 5, we have 3 graphs, and we have to determine which scenario matches each of these graphs. The y-axis is the distance from home. So the further the line gets away from the origin, the further away it is from home. And as it goes along the x-axis, that's time. So the more time has elapsed. So anytime you see a horizontal line, like these two, that means that they're not getting closer to home or further away from home. It's constant. So nothing is happening except time is continuing on, because time doesn't stop. But distance from home can stop, so that's why you have a horizontal line here. So A matches this graph because Arnold started from home. So all of these are starting from home. The distance is 0. 0 time, 0 distance from home. So that doesn't change. And walked to a friend's house. So remember, the steeper the line, the steeper the rate of the change. So if it was this steep, that means the person's going very fast. And the less steep it is, the slower the person's going. So this helps us out that he walked. So we know it's not a really fast rate of change. But let's see. He stayed with his friend for a while. So he started walking and then stayed with his friend for a while. So we know that it has to be one of these two because he's staying with a friend for a while. He's not getting further away from home or closer to home. That takes this one out. And then walked to another friend's house farther from home. So this one, he's coming back to home. You can see this line represents that he's coming back to home. So the only one that works is walking to a friend's house, stays at a friend's house, not getting further or closer, and then continues on to another friend's house further away from home. This one represents B because Francisco started from home, walked to the store, so now he's at the store getting whatever he's getting while he's shopping, and then he's walking back home. This graph represents scenario C because Celia walks to the library at a steady pace without stopping. Well, these are the only two that are stopping, and this is a steady pace, a constant rate of change.